Class, today we're working on geometric series from Chapter 11, Section 5. Please work through the first few problems, 1, 2, 3, 4, 5, and then 7. Simplify those expressions, and then I'll show you the solutions, and we'll check then. The first sum, you should get 193.75. The second problem, 128. The third problem, negative 22. The fourth problem, you should get negative 60, negative 70. It looks like negative 75. The fifth problem, we should probably have a minus in there. If you simplified that, you should get 12/5. And the last one, you should have an answer of 2/3. Those should all be reviewed, so that shouldn't be a problem, and hopefully those were good and successful for you. Chapter 11, Section 5 deals with geometric series. Geometric series is the expression for the sum of the terms of a geometric sequence. The sum of a finite geometric series is the sum, S sub n, of a finite geometric series, a sub 1 plus a sub 2 plus a sub 3 plus ... plus a sub n, where r cannot equal 1, is given by this formula. S sub n, that's the sum of the finite geometric series, equals a sub 1 times the quantity, 1 minus r to the nth power, all over 1 minus r, where a sub 1 is the first term, r is the common ratio, and n is the number of terms. Let's look at the first example to find the sum of this series. 5 plus 15 plus 45 plus 135 plus 405 plus 1,215. The first term is 5, the common ratio is 3, and we have 6 terms. We could certainly just put these values into our calculator or just add them up on a piece of paper, but we'll use the formula here. The sum is given by the formula a sub 1, quantity 1 minus r to the n over 1 minus r. A sub 1 is 5. 1 minus 3 to the 6th power over 1 minus 3. If we just simplify this, we end up with 5 times negative 728 all over negative 2, which reduces to 1,820. And that's the sum of that series. Now, I worked out the check understanding for you, but look through my work there. Make sure you follow that clearly and carefully. See if there's any questions or issues with any of the work that I've shown, and then we'll work on example 2. Example 2 says the Floyd family starts saving for a vacation that is 1 year away. They start with $125. Each month they save 8% more than the previous month. How much money will they have saved after 12 months? So our first value is 125 after the first month. Our common ratio here is 1.08. Even though it says the rate is 8%, we start with 1 and then we add 8% to that, so it continues to grow. If we just said 8%, then our values would decrease rather than grow. So we have to add that 1 to that 0.08 value. N is 12 for 12 months later. And now I can just put this into our formula. Continuing with our problem, we have 125, 1 minus 1.08 to the 12th power, and then 1 minus 1.08. Simplifying this with our calculator, we would end up with $2,372.13. So the Floyd family would have that much money saved after 12 months. Objective for Chapter 11, Chapter 5 Chapter 11, Section 5, Part 2, deals with finding the sum of geometric series. We have two kinds of series. We could have a convergent series or a divergent series. If the common ratio is less than 1, or the absolute value of the common ratio is less than 1, then the series converges to a sum. We might call it a limit. However, if our series diverges, that would be when the absolute value of your common ratio is greater than or equal to 1. The series diverges. It has no sum, or we could say it approaches no limit. Let's look at example 3. Decide whether each infinite geometric series diverges or converges. Then determine whether the series has a sum. Well, I have this sum of 2/3 to the n power from n to infinity. Clearly we can see that our common ratio is 2/3. The absolute value of 2/3 is less than 1, so we know our series converges. And therefore it has a sum. We don't know what it is right now, but we know we can add those numbers up to infinity and they will come up with a value, a specific value, so it has a sum. Example B, we can see that our R value, common ratio, is 3. The absolute value is 3 is greater than or equal to 1, so our summation diverges, our series diverges. Therefore, it has no sum. If we simply look at the numbers 2 plus 6 plus 18 and we add those forever, certainly we do not get a value that sum gets closer and closer to. Go ahead and look at check understanding 3. Determine if each of these series has a sum and name the common ratio to make that determination. All right. Check understanding A. The R is 1/5. The common ratio is 1/5, which is less than 1. The absolute value of that R value is less than 1, so it converges. If I added those numbers forever, I would get to a sum. I would approach a limit. B, the R value is 2. Absolute value of 2 is greater than or equal to 1, so it diverges. This series has no sum. It has no limit. We have a formula to determine the sum of an infinite geometric series. If the absolute value of R is less than 1, we know our series sums to, or it converges to, S, that's our sum, is the first term, a sub 1, all over 1 minus R. R is the common ratio. So I can just use that little formula to determine the sum of an infinite series as long as I know that infinite series converges. Let's look at example 4. The weight at the end of a pendulum swings through an arc of 30 inches on its first swing. After that, each successive swing is 85% of the length of the previous swing. What is the total distance the weight will swing by the time it comes to rest? The largest arc the pendulum swings through on the first swing is 30. So a sub 1 is 30. So let's name our parts. A sub 1 is 30. The common ratio is 0.85. I could just put that into our formula, S equals a sub 1 over 1 minus R, and then simplify. 1 minus 0.85 is 0.15. 30 divided by 0.15 is 200. So the total distance the weight is going to swing on the pendulum will be 200 inches. Now go ahead and do the check understanding that I have written there, and we will follow that up with checking your results. All right, I think you can see them there. Your common ratio I've written for you. You should be able to see that. Now use the formula to determine the sum of these converging infinite geometric series. All right, there I have shown the work. For the first one, the common ratio is 1/2. So I'll have 1, that's my first term, divided by 1 minus 1/2. So I have 1 over 1/2, which is simply 2. If I say 1 plus 1/2 plus 1/4 plus 1/8 plus 1/16 plus 1/32 plus 1 over 64 and add that up to infinity, I get closer and closer and closer to the number 2. So we say the sum is 2. For the second one, I'm going to multiply each term by negative 1/2. So 3 times negative 1/2 is negative 3/2 times negative 1/2 is 3/4, and so forth. So my summation is 3 over 1 minus negative 1/2, which equals 3 over 3/2 simplified. I end up with 6/2, which is also 2. So if I take that series and sum that up to infinity, I will get closer and closer to the number 2. So we say the sum of that infinite series is 2.